posterity. Okay.
There we go.
All right, so this is gonna come into play and it's been on tests. So if this has nothing to do with trig, a line tangent, that means it's touching the circle. It's perpendicular to the circle, to the radius at the point of tangency. So we'll see some questions like that, and there was a question on the SAT. It was either a SAT 5 or 6 that I saw this on. Okay, so we're gonna fill out this chart just to get you going. So if the radius is 2, the diameter would be 4, the circumference would be 4 pi, and the area would be 4 pi, which is a little unusual that the area would equal the circumference, because I think this is maybe the only circle that does that.
Right.
So keeping everything in terms of pi, which they usually do, can you take a couple seconds and fill out this chart?
Could you put the formula somewhere just so that?
Yeah, so the two formulas are area is pi r squared. It's an r. Or pi d if that's faster. And like I said, we're going to get into harder questions pretty soon here. So I'll give you time to fill out the chart. This is our very intelligent group. So if the diameter is 6, the radius is 3, the circumference would be 6 pi, and the area would be 9 pi. So if the circumference is 10 pi, the diameter would just be 10, the radius would be 5, and the area would be 25 pi. I'm sorry that this glass doesn't provide a good surface for me to write neatly. So if 16 is pi r squared, that means that the radius is 4, diameter 8, circumference 8 pi. Okay. So can everybody just say, yes, we're good?
Yeah.
Okay, Zoe's, are you good?
Yeah.
Okay. Addie, you're good, and Ines, you're good. So now, let's fill this out, doing the same thing. You're given one bit of information, and you have to extrapolate everything else. The first thing you have to do is get the radius. So on test day, that should be your focus. So I'll let you do this. This is how you'll see it on the test. But since it's been a while since you've had geometry, I just wanted to review this so that when you get to the harder questions, you'll be okay. What happened to me? Well, it's all right. Okay, let's go through this. Okay, if they give us the circumference, so that's pi d. The diameter is going to be 24, the radius 12, and the area will be 144 pi. To jump over to 3, if the diameter is 12, the radius is 6, circumference 12 pi, area 36 pi. And then down here, if DF, if EO is 4, they just gave us the radius. DF will be 8, circumference will be 8 pi. And the last one, if the area is 64 pi, that means the radius is 8. That means that the diameter is 16 and the circumference is 16 pi. So everybody okay? Just say, we're good. Anybody out there? Are you good?
We're good.
Okay,
good.
thank you. Okay, let's try a book problem. Hopefully you have all this down. The only problem is. Okay. So I'd like to first go to page 345. I hope this is a good one. Number 17. That might be. Let's see.
That's like a pi r squared h one. Cylinder.
Oh, yeah, but first let's do on 344, sorry. Let's do number 11. So work ahead of me if you can. Come on, make a good circle. That's not very good. Okay, so if we have O as the center and PR and QS, and we already know that the circumference is 144 pi. So the arc of PS, so if is twice the value, twice the length of arc PQ. So my drawing doesn't show this. That's 2x. This will be 2x. So we know that 2x plus x equals 180. 3x is 180, so x is 60. We want to try to find the length of QR, which would also be 2x. So 2x is 120. So basically we need 2/3 of the circumference well, we need 1/3 of the circumference, right? Because 120, we're going to get to this part, but 120 is actually 1/3 of the circumference. So 3 into 144 pi. So the answer would be 48 pi, which is B. So, Ines, are you good with that one?
Yeah.
Sehana
Yeah.
and Zoe in Uniontown
Yeah.
and Zoe in Hershey
Yeah.
and Addie, you're good. Just nod your head because I can see you. Okay, that's good. All right, so now I'd also like to try, and we're going to get into more of those arc sector things in a little bit. So the next one would be, yeah, let's do the next page since you're right there. 345. Now we're going to be doing solid geometry next week, but we have a cylinder. Okay, and it has a diameter of 8 inches and a height of 12. So they give us the formula for a cylinder. It's just pi r squared h. So the radius will be 4. And they leave it in terms of pi. So it's 4 times 4 times pi times 12, which is 192 pi, which is answer choice C. I know we're doing more solid geometry next week with the I had to decide whether to do triangles or circles, and I decided to do circles tonight. So there's going to be some interposition between the two. Okay, let's go back to the packet. On to this next question. Let everybody get there. If the area of a circle is 36 pi, so that's 36 pi. So pretty easy. We get the radius always. The radius will be 6. And we're done. Okay, let's look at this harder one. Now, when you get, again, there's going to be 10% of the test is geometry. But because some of you are aspiring to really high scores, we wanted to interpose some harder questions in here. So in the figure above, the 4 circles are the same size. Each circle is tangent. That means it's touching, and it would be perpendicular right here. Okay, so you just fill in what you know. So the center, so basically the smaller square, and I'll just pull it out, it's 9. So if s squared is 9, say, Hannah, what would each side be?
3.
Very good. So that means each of these halves is 1.5. So this would be 1.5. Oh, it's so hard to write on this glass.
I can zoom you in maybe a little bit.
I don't know as though that would help. So this is 1.5. This is 1.5. So you just fill in what you know. You might not see the route to the answer. This would probably be a medium one. So 4 times 1.5 is 6. So 6 times 6.
I'll zoom back out.
Thank you. The area of the larger square has to be 36. So again, I just have to get you used to sort of being an architect and hacking up the drawing and just go with what you know until you get to the end. So, Addie, you're good with that one? Zoe Robson, good?
Yeah.
And Zoe Latham.
I'm good.
And what about Sehana
Yeah.
and Anish?
Yeah.
Okay, thank you. This is a harder one. We have a composite figure, so that means we have a triangle plus half a circle. Now, we're going to do triangles in solid geometry next week. We can't, to cover all the geometry on the test in 2 lessons, that's intimidating enough. So the triangle is going to be pretty easy. It's just going to be half the base times the height. So the triangle area will just be 2. So I pretty much know that's not right. Now I have to get the radius. After we do next week's lesson, you'll have these isosceles triangles, the special right triangles memorized. But tonight, we have to back up and use the Pythagorean theorem. But after next week, you'll know right away what this is. So that's the square root of 8. And we take out a marriage of 2's. And so we're going to get 2 square root of 2 for the whole diameter. So the radius is half of that. It's just the square root of 2. So we only have half a circle here. So that'll be 1/2 times r squared, which is the square root of 2 squared.
And pi, right?
Yeah. So that'll cancel the radical and the exponent. So that's just plus a radius. Or plus pi, I'm sorry. And so 2 plus pi would be b. So that was a little, I mean, after next week, you'll be saying, oh, Mrs. Hesser, it's 2, 2, 2 root 2. Because the special right triangles you'll have in your brain. So with that hard one, I don't know how, let's see. Does anybody have a problem with this one? Ask a question, even though this is an intelligent group. If you have a question, probably somebody else does. Everybody's okay with this? It's a hard one. So let's go on to the next page. Okay, so if you have shaded area, which you could likely get. So 10% of the class of the test will be geometry. It used to be a third. So that's about, what, about 5 or 6 questions
There
or,
are like 44 math questions total.
so it's like 4.4 math questions, right?
Mhm.
But let's say 5.
Right.
You know, that's 50 points you don't want to miss. So we can't get this shaded area, but we could take the square minus half the circle. So I don't know if your geometry teacher gave you exposure to these. So if PQ is 2, the area of this square would be 4 minus, we only want half the circle. We have to get the radius. The radius is going to be 1. So that'll be minus 1/2 times pi, which will be 4 minus pi over 2 if we rearrange it. So is that okay for everybody? Addie, you're good? Inesh,
Yeah.
Sehana,
Yeah.
Zoe Robson,
Yeah.
and Zoe Latham.
Yeah.
Okay, great. Now this is a hard one. Like I said, because this is an intelligent group, you're gonna
I'm
get
just
bigger.
gonna try to get the whole question on you.
Okay, so in the figure above, the 4 circles have the same center and their radii. So this radius will be 1. This one will be 2. This will be 3, and the big radius is 4. And you can work ahead of me if you'd like. So we need to get the large shaded ring, which is this donut here. So if I change colors, okay. So if to get this, I'm going to take 4 pi r squared or pi times 4 squared, which is 16 pi. This would be a definitely module 2. And then I take the whole donut hole, everything that's inside of that, which is going to be the 3, right? Because I want to obliviate all of that. So that'll be 3 squared, which is 9 pi. So the outer ring is 7 pi. And the inner ring would be, so we're trying to get this donut. So we're going to do 2 squared, which will be 4 pi, minus this little donut hole, which is 1 pi. So that's 3 pi. And so the ratio of the small to the large will be 3 to 7. And I'm just trying to expose you to harder questions and just sort of impart with you the ability that you just take a step of faith, put one thing in, next thing. Addie, you're good with this one? Inesh,
Yeah.
Sehana,
Yeah.
and Zoe Robson,
Yeah.
and Zoe Latham.
Yeah.
Okay, good. Okay, I would like all you to try this one. Just take an attempt and try it. So did everybody get C? Ines, did you get C?
Yeah.
Sehana,
Yeah.
Zoe Robson,
Yeah.
and Zoe Latham,
Yeah.
and Addie. This is such a smart group. Okay, next page. And like I said, this is sort of warming you up. Again, if I had to decide whether to do triangles or the circles, and I decided to do the circles. So this is a pretty hard one. It would help if we had the triangle lesson. So we get the area, and I know I always have to get the radius. So if pi r squared is 25 pi, that means the radius has to be 5. So this would be 5 and 5, and I have to get BC.
I think they all know that's just 5 square roots of 2.
So that would just be 5, 5, since they're both, these radii are all equal. And that would be 5 square roots of 2. After next week, you'll have that at your mental fingertips.
You could use the Pythagorean theorem
Yeah.
if you forgot.
I could always do the Pythagorean theorem if you forgot about but next week,
Oh, they give you that on the formula page though too. On the, at least on the SAT. Those 45, 45, 90 triangles.
so that'll be 5 square roots of 2. Okay, let's try 8. A circle is in the square. So we have to be careful here. So we have a square. And a pretty pathetic circle. So the area of the square is 144. So that means this side's 12 and this side's 12. Can anybody shout out what would be the circle? What would be the circle feature that would be 12? Anybody see it?
Diameter.
It's going to be the diameter. Yes, the diameter of the circle will be side of the square. So then the radius is 6. And so the circle would be 36 pi. Okay, we're all good. Now this one is crazy because this one we had in the packet, and then it was on it. Then when the book came out, it was in the book. And when that,
We wrote this question years and years ago.
yeah, but we wrote
There
this
was no
question
book.
years
There
ago.
was
There
no
was no
book.
book.
Yeah.
So this time it's a little harder. I'm going to do this one and let you try the book one. Okay, ready? This time we have the square in the circle. And so now the diameter of the circle will be the diagonal of the square. We're supposed to get a side of the square. So we have the area of the circle, so let's get the radius like we always have to do. So the radius would be 3 square roots of 2. So can you enlarge that a little bit?
Or I'll just draw maybe draw you a new square.
What's wrong with my square?
Well, so you're saying that is 6 square roots of 2.
Yeah, the whole diagonal will be 6 square roots of 2. Is everybody?
Oh, that's hard to write on this thing.
I know, I'm so telling you.
Square root of 2. Okay, so they just want a side.
So you could either figure out, so that'll be, let me just mark this so you know. That's 3 square roots of 2 times plus 3 square roots of 2. So that's why that's 6 square roots of 2. But then we want to get a side of the square. And so after you do those triangles next week, you'll just know it's a 6, 6, 6 square root of 2 circle. Right now, you could probably do x squared plus x squared is 6 square root of 2 squared And so we would get 2x squared equals 36 square roots of 2.
Squared, so that's 72, right? Square root of 2 squared.
Yeah, square root of 2 squared, so that's 72. But that's not gonna work. Well, maybe it will.
Well, then you divide by
Yeah.
2.
We're gonna divide it by 2, get 36. If x squared is 36, then x will be 6. That's a hard one, but like I said, this is a group going for really high scores. This was in our packet before it was in the book, so I'd like you can look at this and then try this book one. Which honestly was in after we're going to 506 number, a hard one. They consider this hard. And I'm going to sort of throw you in the deep water and have you try this. So we're in module 2, we're at the last question.
They wouldn't expect many people to get this one right.
Yeah, this is getting into Harvard question. So Addie, did you get A on that hard one? Oh, good. Inesh,
Yeah.
good. Sehana,
Yeah.
Zoe Robson,
Yeah.
and Zoe Latham.
Yeah.
That was a hard one. You guys have to be honest with me. That's the hardest one. And so it was in our packet years before it was on the test, so we're in tune here. Let's go back to the packet. I'm going to try to give you every circle problem I have, or it's a big Peloton circle lesson. So a child's wagon has a radius of 6. And so if I put a little mark on the wagon, on the tire, and it travels 100 times, this isn't a very good picture, but what's the, every time, what feature of the circle do we need? Can somebody shout it out?
Every revolution is the blank of the circle.
Yeah, every revolution is the blank of the circle. Anybody see it?
Circumference.
Circumference, good. High five. Okay, so we have 100 times 2 pi r, which is our circumference. We know the radius is 6. So that would be 1,200 inches. But notice they're asking for it in feet, so I have 12 inches in a foot. So that would be,
Yeah, pi still, right?
yeah, still the pi is there, sorry, yeah. So that's 100 pi, and usually you don't have to know what pi is, but here it would be 314. So like I said, I'm taking you into like a, I don't know what to call it, treasure hunt of circle problems. Okay, let's go to this one. The number of square units is a word problem in the area. So that would be pi r squared is equal to the number of units in the circumference. So we can divide by pi. And so we can now find out that the radius is 2, and so the area of circle O will be 4 pi. So that was the circle we had in the beginning where the circumference was equal to the area. So I just put that one in there so you wouldn't be intimidated by a word problem. The next thing, arcs and circles.
Yeah, arcs and sections.
Okay, so I guess everybody good? Sehana good?
Yeah.
Inesh?
Yeah.
Okay, Addie, just nod your head, honey, because I can see. And Zoe Robson
Yeah.
and Zoe Latham.
Yeah.
I'm bringing up memories. I hope you had a good geometry teacher. Okay, the next thing we're going over in the packet is arcs and sectors, because they test on this. So a circle is 360 degrees. The arc, that would be the minor arc. It's a fraction of the circumference. And then if we have a sector, that's like a pizza slice. So we have a formula down here that you can use.
Yeah, that we can use.
So anyway, so we find the circumference of the entire circle, put the degree measure over 360, get the fraction, and then multiply the circle by the fraction. So sector, the same thing. So we're just going to get the fraction, which is something over 360, and then we're going to multiply. So let's try a book one first. So let's go to page 420, number 17. I hope it's there.
It is.
Okay, take a minute to try that one. Okay, this one's pretty easy. So we'll just do it. If O is the center, the measure of arc RS, I know this is not drawn to scale, is 100 degrees. So what's the measure of the angle ROS? It also will be 100 degrees. And we did this before. Does anybody remember what the inscribed angle would be? What that one would be? Anybody shout it out? If the central angle is 100, this guy's smaller. Does anybody want?
Half.
What?
50.
Yes, half 50. Great job.
They like that theorem lately. I don't know
Yeah.
why.
Yeah, that has been resurrected on the test. So what you would put in this question is just 100, and you don't have to put the degrees because they already embed degrees in the problem. Okay, so let's go on to the next page of the packet. And these are just to be thorough. These are just pizza problems with some pathetic pizza and pepperoni. So we're just going through this in this little exercise. The crust is the arc, and the sector is the whole piece of pizza. Okay, and the crust does not affect the topping. So pizza's 8 inches across, so the radius would be 4. So the whole pizza would have 8 pi inches of crust. And this is just to get your familiarity up. So then if we square the radius, all the topping would be 16 pi.
We just assume that that's the topping goes over the entire pizza, right?
Yeah.
Okay.
So here's a pizza with a 90-degree angle. Obviously 4 slices, so we just need 1/4 of 8 pi which would be 2 pi. And then down here, the topping would be 1/4 of 16 pi. So that's 4 pi. Okay, let's try this one. If we have it 12 inches across, that would be 12 pi for the whole crust. The radius is 6, so all the topping would be 36 pi. Now, if we're dealing with 40-degree slices, 40 over 360, I know that doesn't look like a 40 at all. 40 over 360 is going to be 1/9, because there's 9 of these in the whole pizza. So 1/9 of 12 pi, and they would just reduce it. That would be, when we divide by 3, 4/3 pi. And then the square inches of topping would just be 1/9 of 36 pi, which would be 4 pi. Okay. That was just because I know it's been a while. We're going on to the next page, but before that, I have a book one, but it has radians in it, so we're gonna have to wait for that one. Okay, so let's go on to the next page. Let's try this one. A circle with a diameter of 12. So the radius is 6. So the whole area is 36 pi. We're just dividing by 6 sections. So the pizza slice of a sector would just be 6 pi. Okay, here we have a different scenario. A circle with area 16 pi. So we have to get the radius. They don't give us that clue. So the radius would be 4. And so if I drew the circle, it's going to be, we want the perimeter of the whole slice. So we want 4 plus 4 plus 1/8 of 2 pi r, or 1/4 of 8, 1/8 of 8 pi would just be pi. So we would have 4 plus 4 plus pi, or 8 plus pi for that one. Let me just ask everybody, Addie, does that make sense? It's because they're asking for the perimeter. Zoe Robson,
Yeah.
Zoe Latham.
Yeah.
It's too bad we can't have a field trip and everybody meet, and then this would be the crust. Okay, everybody try this one. You're finding this area here. And you know that's 90 over 360. So try to beat me to the answer.
Is that a 2? Oh yeah, 8 times 8. I see. Yeah.
Did everybody get 16 pi? Because we take the degrees and we get the fraction, which is 1/4, and then we have pi times 8 times 8. So we're going to take a segue. I know this is good. How many, let me ask you. Addie, have you seen radians in a math class? Yes. Inesh,
Yeah.
Sehana,
Yeah.
Zoe Robson,
Yeah.
and Zoe Latham.
Yeah.
Okay, so the math teachers are doing their job. So I'd like you to turn to page 296. And we're going to look at number 10, or no, number 6.
2, okay. There is one on them. There is a number 10 though. It's a circle. It's on the following page.
Okay. Well, 296, number 6. Yeah, we'll get to that in a second. Okay, so we just did this. So if it's 90 degrees and we're converting it, we have to convert it to radians. I usually do 180 is pi, but if you have on the back of our packet, we gave you the unit circle, but you don't have to know the unit circle for the test.
Well, for the ACT, you kind of do.
Oh, okay, for the ACT. So it should be pi over 2. Is everybody good with that?
Yeah.
So that would be answer choice C. And let's go to the next page. Let's go to 2. Because Jim found another one. Let's go to 298. Again, we just want you to be so primed for this. We're doing
Number 10.
number 10. So we have a triangle in a circle. Oh, it's so sad. Come on, make it a circle.
No, it's not doing that today for some reason.
It can do it. Come on, screen.
Oh, there you go.
I had faith in you. Okay. So we have F, G, H. You can work ahead of me. Arc FG is equal to arc GH. So if these arcs are equal, this is an isosceles triangle. And angle G is 30. And so next week, we're going to learn that an isosceles triangle, the sides opposite are equal. No proofs on the test. So if we have 180 minus the 30, and we're taking 150, and then we're dividing that by 2, each of these angles would be 75. And hopefully that makes sense to everybody. Again, I'm just trying to, of the 6 geometry problem, well, I guess if you did, well, 2 modules, yeah, you'll have about 6 questions. So hopefully everybody's good on that one. So let's go back to the packet. This is a hardest one.
They could probably handle it though. These
I know,
so smart.
I know they're smart, but let me just give them a little springboard to start.
Get it all in
Okay, so arc 9 pi, so we have to get the radius. I'm gonna let you loose in a second, guys, but you can work ahead of me. So we have, that is 9 pi. So what fraction of the circle is 30? That's a 30, sorry. So it's gonna be 1/12. So we're gonna have a 1/12 of 2 pi r is 9 pi. So for you intelligent scholars, see if you can get the radius out of this, and then you want the area of this sector. And this would definitely be
It's 2916 if you want the. Yeah.
and again, I really took you into deep water here. So the hardest thing was to get the radius. But I mean, I'm trying to expose you to harder questions. So Zoe Latham, are you good with that one?
Yeah.
Okay, Zoe Robson,
Yeah.
you all could be math teachers one day. Sehana,
Yeah.
Inesh,
Yeah.
Good, and Addie, are you good with that hard one? You guys have to be honest if. Okay, now we're going to the next page. Can you give me some coffee?
Yeah, I might just make some.
Okay, so I'd like you to try 5 of these problems. Any 5. It goes, there's 10 problems, I think. So try any 5. We're gonna go through them all, but I'm gonna give you a few minutes to try 5 of these. And we're gonna go through them all. And so what I'm doing is trying to equip you, no matter what you see, you will have seen it here before. So let's go over these. You might not have gotten through all 5. So let's do number 1 if you tried that one. So in the figure above, A, B, C, D is a rectangle, and BC is twice BA. So if BC is 12, and this is 6, now do you see this half a circle, looks like a basketball court to me. I could fit this right in here, so I don't have to add it on and then subtract it off. So to fly like an eagle above the problem, you can just see that that had smoothed in there and you would get 72. And I'm assuming everybody sees that one. That's not so bad. But you want to work smart. Okay, for this petal one, so the whole big circle, the whole big thing would be pi r squared or 144 pi. But then here, the radius would be 6. So instead of doing 4 quarter circles, I'm just going to do 2 big circles. So 2 circles times pi times 6 squared would be 2 times 36 or 72 pi. And so if I subtract that from 144, and it does sort of look like, so 72 pi would be the shaded region. Again, I just tried to create every kind of a problem I could that you would see. So stop me if I don't, please shout out or say, stop or something. So let's go on to 3, which is more about arcs, which isn't too bad. Oh, I have to bring this down a little bit. So if this is 160 and every straight line is 180, that little angle is going to be 20. And so 160 is how many times 20? And so it would be 8. So again, I'm just trying to give you a little workout training in math. This one would be considered pretty hard. Okay, in rectangle ABCD above, arcs BE and CE are formed by quarter circles with centers at A and D respectively. So the radius of each of these quarter circles is 1. So the whole rectangle would just be length times width, or 2 times 1 or 2. And then this is half a circle and that's half a
Well,
circle.
they're each a quarter. They're each a
Or
quarter.
they're each a quarter. I'm sorry.
So I have to.
So I'm adding a half total. I'm subtracting a half. So a half, yeah, my mind got ahead of my something, I don't know. So we have 1/2 of pi r squared where the radius is 1. Yeah, you could do 2 quarter circles. So then I'm going to subtract pi over 2. And so the closest thing would be 2 minus pi over 2. So since that was a pretty hard one, I'm just going to ask my audience who is going to excel on their tests. Zoe Latham, do you see that?
Yeah.
Okay, Zoe Robson.
Yeah.
We should have a field trip to Hershey and go to Hershey Park. That's what. Sehana, do you see it? Inesh?
Yeah.
Sehana?
Yeah.
Addie, nod your head. Okay, so I just want you equipped. So let's go to the next one. This is a little strange.
Just gonna zoom in a little bit.
Okay, in the figure above, the diameters of the 5 dotted semicircles are equal, and they lie on segment AB that has a length of 20. So this is 1, 2, 3, 4, 5. So 5 into 20, each of these diameters would be 4, which means the radius would be 2. And then we have to see So we have one circumference, again, another circumference and a half. So basically we have 2.5, 2 pi r. I'll just bring this down here. That'll be 5/2. And we know the radius is 2. Whoop, that's a 2, sorry. Your computer went dark. And so that would be 10 pi. Just a bit of an unusual problem. Like I said, they make it hard to get a perfect math score, but you can do it. Okay, sometimes I put easy ones in here, so this is an easy one. The circle was, so that we know the radius is 6. I want an arc, so you don't give them the sector. So if the radius is 6 and I'm 90 degrees, so we've seen this before, so 90 over 360, I only need 1/4 of 2 times pi times 6, 1/4 of 12 pi, and I would just get 3 pi for an answer. And so that's not so bad. This one is a little bit harder because it gets into that tangency. So if the line is tangent to the circle, and we're going to get to one that I saw on a test that did test on this. So this is going to be 90 degrees right here. This whole big angle.
So it's perpendicular at the point of tangency?
Yes. And that's what this, you have to pick up from this. And that's something they can test on, as you'll see in a minute. So I have to fill in what I can. So if this is 50, I don't know how I'm going to get all the way over to y, but that's all right. So this is 130. And so these radii are equal. So I'm just going to bring that obtuse triangle out here. Oh, not too good. So that means the triangle's 180, which we'll do next week. So that means that each of these angles is going to be 25. Each of these little guys. So then 90 minus 25. And if you didn't know that circle was perpendicular, you'd be sort of lost there. Okay, so I'm going to sort of ask about that one. Sehana, you good with that?
Yeah.
Be honest if you're not. Zoe Robson,
Yeah.
it's a hard one. I took you, Zoe Latham.
Yeah.
I think we should go, except for when I took my kids to Hershey Park. Inez, you're good? Okay, and Addie, that hard one was good. They took me on that, my kids were like 10, 8, 6, and 4. And they took me on that sky thing that goes all around the park. And then they started swinging the sky thing and getting their mother all unhinged. Okay, this one's easy. In the figure above, the circle with center C has a radius of 3. Circle A is a radius of 2. Circle B is a radius of 1. So I just add these up because I want the perimeter of the triangle. And so that's going to be 12. Okay, now we're on the Pac-Mans. In the figure above, ABCD is a square, so I know these are all 90. These are the centers of the circle. This would be a hard one at the end. AB is 4, so this is 4, 4, 4, 4. Now, unfortunately, I can't take two circles and subtract the square because there would be an overlap. And so if you were an architect, you couldn't do that. So basically, this Pac-Man is going to be 3/4 of pi r squared, where the radius is 4. So that is going to be 12 pi for one Pac-Man, 12 pi for the other one, so the total will be 24 pi. And again, you might be tempted to get two circles and then subtract that square, but there would be part of it you wouldn't, it would be covered twice, so we can't do that. So I'm assuming everybody's good with that one. This also was a hard one. So a fan is created by gluing paper to 7 sticks that are joined at one point. So basically we have, if the fan was opened all the way, each of the angles would be 30. But the fan's only open to 5/6 of the 180, which would be 150. Now, even if it's open 5/6, you see, I would still have 6 sections. That's the part you have to notice, because each of these sticks that holds the fan. So basically, I'm going to divide 6 into 150. And I would just get 25 degrees. Okay, let me just do I wish I,
Roll call.
roll call. Yeah. Zoe Lapham, are you good with that, Zoe Robson?
Yeah.
Say Hannah. There's a roll call, and Idesh. Yeah. And Addie. You're good. Okay, let's try a hard book one now. It's a popular question, so I know we haven't had triangles yet, so it's a little, like I said, I had to decide what to do first. So we're gonna go to page 287. And we're gonna do question 4 at the top. So I'll let you turn there. While I try to draw this. Come on, fix that circle. Looks like an apple,
Mhm.
something, okay. No,
Not gonna do
come on. That's a bad circle.
it.
I'm challenged. This should be a simple thing. Okay, I'm just gonna deal with, no, I'm not. I want that perfect circle. Come on, you know, board, how to do this. Okay,
Close enough.
yeah, so we have a triangle. You probably looked ahead at this. So in the given figure, this is supposed to touch. We have O, you could work ahead of me, B, C. This is point A. And again, we haven't had triangles, so OB and OA, so the radius is 6. BC is tangent at B, so that means this is a right angle. That's where that pointed tangent.
AC is also 6.
And AC is also 6. So basically, and again, this is triangles.
So they want the
coming-
triangle minus the sector, I guess?
Yeah. So this is our right triangle here. And so we have 6, 12. Now, to get the area of the triangle, we have to do 1/2 the base times the height. And we have a little trouble because we don't have, how do we get this base? So what you sort of have to commit to memory is that there's only one triangle in the universe.
One right triangle.
One right triangle in the whole universe where one side is twice the other side. And that would be a 30, 60, 90. So the big hypotenuse is opposite the 90. We're gonna do this more next week. So it's, I know it's pretty crazy to do all this will be 30, because that'll just be X. And this base, which we need, will be X square roots of 3. So we get to get the area of the triangle, not so bad. It's 1/2 times 6 times 6 square roots of 3, which would be 18 square roots of 3. And then what I'm gonna have to do is take out this sector, which, I mean, my drawing's not perfect, so I apologize. And so this is going to be 60. So you'll know after next week, if one side's half of the other and it's a right triangle, you're gonna have 30, 60, 90. So if it's 60, we're taking away what fraction of the circle? We're taking away 1/6 of pi times the radius squared. So that'll be 18 square roots of 3 minus 6 pi, which is answer choice B. Now, I know that was a lot.
And we didn't even do triangles yet. So.
We haven't done triangles yet, so, but I had to make a call on which to do first. So anyway, this you'll know by next week. If it's a right triangle and one side's half the other, the only thing it can be is a 30, 60, 90 triangle. Where this is 2x, this is x. Okay. So now, let me ask, so the answer for this one was B. So say, Hannah, do you see it? Inesh?
Yeah.
Okay, so Hannah, do you see it, honey? She might have stepped away. Oh, maybe okay, she got it. So Zoe Robson, are you okay with that really hard one?
Yep.
And Zoe Latham,
Yeah.
we want to get scholarship money out of this. And Addie, just bob your head up and down. Too bad you can't just put a check by your name. You know, they should have that feature.
There's a lot of concepts in one problem. Like you have to remember that it's 90 degrees because it's perpendicular.
Yeah.
You have to remember.
And if this group wasn't so intelligent, I wouldn't try that on you now. But I did, so there we go. Okay, let's go on to radians, which thankfully you guys have had. So we're back in the packet, which is, here we go. Okay, so you know 2 pi is 360. And this is just, since you've all had this before, we had some kids on Sunday who never saw this before. So this is how it works. And they're coterminal. So anyway, how I do this is I just do 40, I put the degrees on the top, and then I do a dimensional analysis where 180 is pi. And if you have another system that you're comfortable with, don't go with mine.
And also all of these, if you really know your unit circle, you just know what these are.
Yeah,
But these are all pretty common divisions.
and then with the degrees, it's the same thing. I take pi over 5 radians, pi in the denominator, 180 in the numerator. 180 divided by 5 is 36. So let's try this one and you can work ahead of me. Like I said, if you have another system for conversion, just use that. Or if you have,
You could say 2 pi is 360, but
Yeah.
the math's gonna be the same.
yeah, you could do 360 down here and 2 pi up here, but I just like doing, so we have to go to radians. So I'll put the degrees down here, the 180 and the pi. And so that's gonna, 45 into 180 is 4. So if you have your unit circle memorized, that will definitely be pi over 4. 60 degrees. So if we're doing and you can work ahead of me. And like I said, if you have another method that you feel more confident with. Okay, so this would just be pi over 3 or 1/3 pi. Okay, 5 pi over 6 radians. If we're changing that to degrees, pi over 180. And so this one would be 150. And so 7 pi over 4. Pi is 180. So 7 times 45 would give us 315. So I want to do a couple book ones. We only have one more big thing to go over, which is good because we have more grammar tonight. Okay, so I'd like to do 424, number 6. Okay. Addie, did you get 192? Yes, Inesh?
Yeah.
Good, Sehana?
Yeah.
Zoe? Robson? And Zoe laughing.
Yeah.
Okay, let's try another one. The last thing we have to conquer is the circle on the coordinate plane, which can get a little bit hairy. So I'd also like to go to 499. A little bit harder one. So I'll let you try this one first. You can either number 19. You can either change these both to degrees first or add them together, whichever you want. So try to beat me to the answer. And you can see this is in a harder section. Or we could just add them together, but we have to be careful. Because we don't have the same denominator when we add these. So I have to multiply this times 4, so I get 8 pi. Either, no matter how you do it. I'm gonna get fancy and do a green. C. Okay, so the roll call. Zoe Latham, did you get C?
Yeah.
Oh, you guys are so smart. Zoe Robinson, did you get a C?
Yeah.
Okay, Sehana,
Yeah.
Anish,
Yeah.
and Addie, just bob your head. Good. All right. Okay, we sort of conquered Radians. So let's go on. Oh, we have a page to race through here. So we'll just do this fast. This would be like a homework thing. So just try these ahead of me, okay?
You could do the multiplication, or if you really remember the unit circle, just do it from memory. Like you should know what pi over 6 is if you looked at a unit circle.
What?
That's the first one.
I know it's 90 degrees.
I know.
I know it's 90 degrees. Don't give me a hard time.
I'm not.
Okay. Let's just go through these. So pi over 6 would be 30 degrees. 120 to radians would be 2/3 pi. Pi over 2 is just 90. And 3 pi over 4 would be 135. So let's go to the last, everybody good with that, I'm assuming. Let's go to the last page of the packet. Because I put one, the very last page. Unfortunately, these aren't numbered.
Make sure that they have. Oh, you mean that? Well,
Yeah.
let me bring it up in the packet so they can see what you're talking
No,
about.
it's not gonna be in the packet.
This is.
Oh, okay.
She's jumping ahead.
I'm jumping ahead only because this is a convert to radians.
We'll come back to all this.
We'll come back to all that. It's the last thing we have to conquer tonight.
She wants to do
Yeah,
this
I
one.
want to do number 3. So it's the last page of your packet. So if it's 900 degrees, and it's x pi, what's x? So what does 900 over 180 equal? Let everybody try it. Did everybody get 5? Yes. Zoe
Yep.
Latham. Yes. Zoe Robson. Sehana.
Yeah.
Good. Inesh
Yeah.
and Addie. Just bob your head. Okay, we're going back now to the last thing we have to conquer. So as soon as we do this, you get a break. But I first have to ask. Wait, you went
Oh, it went too far.
too far. How many have you, let me just ask you, have you seen this formula, Addie, in a math class? The circle on a coordinate plane? Yes, Inesh?
Yeah.
Sehana, you saw it?
Yeah.
I never saw it.
Hey,
in high
Mrs.
school.
Hessler, do they put that on the formula page for you?
They don't give you this. They don't give you this on the formula page. Zoe Robson, have you ever seen this?
And what's
Yeah.
R is the radius. So we're gonna try to conquer this and then we're done with math. But you can.
this is on every SAT.
They put one of these.
They
on-
love this.
One on every SAT. And I don't know about the ACT, but
Well, the ACT is harder because they might give you an ellipse. Sometimes they ask you to find the foci of an ellipse.
okay, so let's go through this very simply. So the center is HK, but notice these are subtracted. So here we have a circle. And the center is indeed 4, 3. And then the radius is 3. So it would be x minus 4 squared plus y minus 3 squared is 9. So learning this will give you 10 points. So that's why I want to do every kind of a problem. So let's draw our own circle here. So notice if it's a plus, that's going to be x minus a minus 2. We have to be careful. And so our center will be minus 2 and up 5. And then the radius is 2. And so our circle would sort of look like that.
That's a little sloppy.
Sloppy. So hard to draw it on this screen.
That's good. That's a good circle right there.
We make it eyes.
Yeah, we give some eyes in the mouth.
Okay. So I just wanted this to you to be very familiar because 10 points is 10 points. And we're going to try all kinds of questions. So let's go to the next page.
Yeah, you might get an easy one of these. You might get a real hard one. They're kind of all over the place with this circle formula.
Yeah. So let's do, speaking of that, let's do an easy one in the book. Let's go to page 275, 295 rather, number 3. So work ahead of me if you can. Okay, so if we look at number 3 on the bottom of page 295, lock in an answer. So the center's at minus 8, 6. And the radius is 5. So this would be pretty easy, obviously. This would be x plus 8 plus y minus 6 equals 25, which looks a lot like B. So Zoe Latham, you're good with that one?
Yep.
We're gonna get to some hard ones. Zoe Robson,
Yeah.
okay, good. Say Hannah,
Yeah.
thank you, Inish. And Addie, just bob your head up, honey, yeah, okay, good. So that would be an easy one. So we did this one at the orientation, but I think some people weren't here for that one. So let's see how we're gonna do a hard one. How would they make this module 2 hard? So we already did this at the orientation, but 582 number 20. So we know it's hard.
Oh, now you're completing the square.
Yeah, but we have to complete the square on this one. Yeah, we haven't done that yet. So anyway, we have x squared, and I'm gonna put plus 1x there. And my job is to get the radius. And so we have to complete the square first. So if I divide this 1 by 2, I'll have x plus 1/2. And so if I FOIL this, then I'll get x squared plus a half an x, and a half an x is 1x, which is what I want, plus 1/4. So I have to add a 4th over here too, since I added it to this side. So this one, to complete the square, I'd have to divide this by 2. Whoops. So this would be y plus 1/2. Plus this would be y squared plus 1y plus 1/4 again, because 1/2 times 1/2. So I'd have to add another 4th. So a 4th and a 4th equal a half. And so that's 200 over 2, which is a nice number, which is 100, but that's r squared, remember. The radius would just be 10. And you can see where we are. We're at the very end of the test. So I'll give you a second to process that. Zoe Latham, are you okay with that?
Yeah.
Oh, you are? Okay, Zoe Robson,
Yeah.
Sehana,
Yeah.
Anish?
Yeah.
And Addie? Oh, good, because I mean, thank God this group is all smart. Okay. So.
I know, I can't wait to see how this next practice test goes. I bet it.
Yeah,
Good.
you should feel very confident on your next test. So let's go back to the packet. Oh, we didn't, wait,
Yeah, you have to do all that.
okay, let's try this, wait, I don't know why. Oh yeah, we have to go through this.
Yeah, you just went and picked the book up. I think that's why you got ahead.
I got ahead because of the buffer. Okay, so anyway, this is pretty easy. Define the center. If you're given the endpoints, you just average x and then you average y. It's pretty easy.
So that's the same as the midpoint formula.
Yeah, so we're just gonna take 2 plus 4 is 6 over 2. So the center would be 3. 3 plus 5 is 8 over 2 is 4. So 3, 4 is our center. And so this, we just did this all down here for you. Okay, so on the next page, if you're given the endpoints of a diameter, so you can use the distance formula. That's what Jim prefers. I'll show you what I like.
She likes to draw the geometry.
I like to draw the geometry because I'm more visual.
Both ways you're using the Pythagorean theorem.
Yeah, both ways use the Pythagorean theorem. So let's look at this one. If we have
I'm just gonna bring it. See it.
okay, so I'm just gonna draw the circle. So, do I need to get the center?
They want the radius, so they give you 2 endpoints, so I put those down.
Okay, so I like to draw it. I'll show you why.
They say -4, 6 is 1.
Negative 4, 6,
Yeah, -4, 6 is an endpoint.
and then -8, 10.
Yeah, -8, 10.
So I don't like the distance formula
She
so
just
much.
likes to create a right triangle.
Yeah,
And find the
because
the
I
diameter.
might get messed up with negative signs here. So the distance between the x's, a -8 and a -4 is 4. The distance between 10 and 6 is 4. And so next week we're gonna learn it just be 4, 4, 4 square roots of 2.
But that's the whole diameter, right? Not the radius.
Yeah, so I need the radius, so I have to divide it by 2. Okay,
And if you use the distance formula, it's right there. The math is identical.
yeah, the math is identical. I'm more visual. So I see the triangle and I can get the distance and the distance and I'm not messed up with negative numbers. So let me just ask you, Zoe Latham, would you draw the triangle or would you use the distance formula?
I'd probably draw the triangle.
Yeah, I'm with you on that one. Zoe Robson,
I think I'd use the formula.
okay, Sehana? Would you draw the triangle or would you use the distance formula?
I think I'd use the triangle.
Yeah. What about you, Inesh?
I'd use the distance formula.
Okay, and Addie? Oh, she doesn't have a voice. I'm so sorry.
It's all right.
It's all right, honey. We can see you. Okay, so whichever way you feel comfortable with. Okay, now let's try these. Okay, so try to work ahead of me. And the crazy thing is, Jim, I found one of these questions on test 5 or 6.
Really?
Yes,
And we wrote this packet way, but they didn't even
I
make
know.
a test 6.
They don't even, they have, yeah.
We probably made this packet so many years ago. That's
Okay.
great.
Okay, so if we have center of 3 minus 2, so that's gonna be x, I would just write it out and then try to find the match. Remember, it's gonna be a y plus 2. Okay. So that one's gonna be C. Okay, let's try a harder one. This one is gonna be x, work ahead of me, x plus 2. Just so you have your brain here. And if I score that, I'll just get 10 for the radius. So I know these hundreds are out. And I know I need x plus 2, y minus 4. So I need C for this one. Okay. This one. A circle has a diameter with points, so we just have to average.
A lot of these you could check with Desmos too, if you wanted to, just to make sure.
Yeah, we haven't used Desmos yet, but yeah, now this one, I actually found one of these on test 5 or 6. So if anybody's gone that far. All right, so if it's x squared plus y squared is 25, that's right at the origin. The center. And so this would be r squared. So this radius is going to be 5. Sorry.
Trust us, that's the origin. You can leave it, it's fine. Close enough. Gotta make it perfect.
Okay, and it's tangent.
Or at 0.34.
We're 0.3 over. So this is 0.34. So we first have to get the slope of this line, which would be rise over run, which is going to be 4/3. And
Can
then
you draw that tangent line?
I'm
on-
drawing it.
yeah.
making it darker. Oh, come on.
You just gotta like click over here somewhere.
Okay, so the tangent line would be going down this way. So remember, it's perpendicular at the point of tangency. Yeah, I can't believe I saw this.
Maybe they know already what it is. What's the slope of the perpendicular line?
Who can shout out what the slope of the perpendicular line is? Somebody, if you want to operate on me one day, the perpendicular to this slope would be what? Crickets. No, -3/4. Remember, it's the negative reciprocal? So the only slope that's -3/4 would be A. So let me just go roll call. Addie, good? Because there was one of these. Inesh?
Yeah.
Got it. Sehana, got it.
Yeah.
Joey Robson
Yeah.
and Zoe Latham, good?
Yeah.
Okay,
There was one of these on that,
I'll show you.
yeah, that's interesting.
Yeah,
Well, it's fair game if they're putting it on the test. Then.
yeah, but we had this packet way before the book was published. Okay, so now we're back in the packet, which is here, no, here. Okay, is the point inside, outside, or on the circle?
You could use the distance formula, but they have been asking this question.
Okay, so we want the one that's not in the interior of the circle, or couldn't you just put the numbers in?
I would just use the distance formula.
Okay,
Because look, one of those is the center of the circle. Right?
yeah, because the center is negative,
C is definitely in there.
this is the center. But you can see what we did down here.
Yeah, I just tried each scenario with the distance formula and a few of them are within the circle, but point D is outside. I mean, I guess you could draw it too. You could draw the circle.
I like to see it. Okay, let's go to the next. Okay, now we're doing completing the square, which you guys already did that once. So you know, so if we had the circle,
They don't always give it to you in standard form, so that you have to complete the square, usually twice.
yeah. So Jim just put a page in here to explain how to complete the square, but you guys already know it. So you could just memorize that you have to take this middle number and divide it by 2. So let's try this one. If we have x squared minus 8x, so we're going to divide this by 2. That'll be x minus 4 squared. And then if we FOILed x minus 4 and x minus 4, I hope I'm not going too fast. That would be x squared minus 8x plus 16. And so we would have to subtract the 16.
Which was D, I guess?
Yes, which is D. Okay, let's try one here. Okay. Here's an equation with a circle on the coordinate plane. So I'm just going all scenarios. So whatever you get, if you get an easy one, hallelujah, you know, we're going to divide this by 2. We know this goes through. So that'll be x plus 3 squared, which will give us x squared plus 6x, which is what we want, plus 9.
So that 9 was never there to begin with, so you have to,
Plus-
you just usually add it to the other side, I guess.
So since I added a 9 here, I just add a 9 over to here.
And they're usually perfect squares.
And
Like if you
usually-
see a perfect square,
Yeah,
that's a good thing.
yeah, and so the radius was 8. So since I haven't asked about this, you can see we're coming to the end here. Okay, so let's try this next example, and then I'll ask if you're okay. So again, this time we have to worry about the x and the y because the center is at a minus 8, 10. So we're gonna divide that by 2, so
Well,
we'll
you don't know that. The
Oh.
yeah.
yeah. Okay, so this will be x plus 4. And so here I had to add a 16. So I'll have to add a 16 over here. Here I'll have to add a 25. So I'll have to do that over here. And like Jim said, they're almost always going to be perfect squares. So our radius will be 7. So let me just ask before I go on. So Zoe Latham, are you good with this, completing the square?
Yeah.
Okay, Zoe Robson,
Yeah.
okay, Sehana,
Yeah.
you're all gonna wind up working for NASA. Inesh, good,
Yeah.
and Addie, just shake your head if you're good. Okay, couple of hard ones, so this one. So once again, I like to draw the figure because that distance formula gives me, I don't know. So we have 1, 3. I just like to see it. And we have -1, -3. So I can see that if I draw this triangle, which is pretty pathetic.
So you would just average those points to find the center, I
Yeah,
guess?
to find the center, I'd average them. So the center's gonna be at 0, 0.
So we already know it's C or D.
Yeah. But we don't guess here. So if I
Right.
have my triangle, and that's the right angle. Okay, from -1 to 1 is 2. 3 to 3 is 6. So I'm just gonna do 2 squared plus 6 squared equals C squared. So 4 plus 36 is 40. So that's C squared, so I have to take the square root of both sides. So the square root of 40 would simplify if I took out a 4 as 2 square roots of 10.
You could always use the distance formula too, if you prefer.
I know if you like the distance formula, but I like to see it. So then we're gonna divide by 2 because that's the whole diameter, remember, be careful. So the radius is just the square root of 10. And the center's at 0, 0. So it's beginning to look a lot like D. So take a minute and absorb that. This is way hard.
But they put it on every test. They love this formula.
Yeah, but maybe not, this would be end of the test.
And they don't even give it to you on the formula page.
Yeah, they don't give it to you in the formula page. So Addie, are you good? Just nod your head yes if you're good with that one. Inesh? Sehana, are you good, hun?
Yeah.
Zoe Robson?
Yeah.
Oh, thanks,
Yeah.
Inesh. And Zoe Latham, to that hard one, you're okay?
Yeah.
You got in a group with, this is an intelligent group. Okay, one last problem.
I kind of want to see if they could just do it. Just want to give them a minute to try it.
No,
Just leave it up for just a little bit. I bet a few of you can get this one. This is as hard as they can make it.
this is as hard as they can make it, but I'm still gonna start it here.
All right.
This is, what do I say, uber hard?
Yes, it is. Uber.
What's hard in German? Uber, you don't know.
Square, I think. I can't remember.
uber severe. You could give this to your parents to try. This is our last problem, then we have a break. This up here.
Yeah, that's what I got.
I know, but I'm just showing, I like my marriages.
Mhm. Mhm. And you found the center, right?
Yeah, the center is this.
Oh, yeah. So now you have everything you need for the whole formula for the circle. You got the center and you got the radius.
Yeah. I'm trying to get these off of here. So anyway, if I go down here and make it'll be X.
So it's minus a minus, so +4. And then just a y because it's 0. Two square root of 5 squared, the whole thing, yeah.
So now we're putting in, we want to get 0B, we want to get the y-intercept. So we know from our little tricky thing that if we want to get the y-intercept, x is 0. If we want to get the x-intercept, y is 0. So we're gonna put 0 in for x.
And that's a 20, right?
Yeah, so we're gonna make a divorce over here. Whoop, that doesn't apply. So this will be square root of 20
Squared, right?
squared.
Right.
So we're putting 0 in for y or x, sorry. We're putting,
That's what you saw before.
yeah, we're solving for this. So
And
we'll
that's
have
equal to 20.
16.
And they tell you b is greater than 0 because otherwise there would be two solutions. But
Yeah.
they want the positive one.
Well, wait,
Well, you gotta square root that.
I know,
Yeah.
I caught
I
myself.
got myself.
So we subtract the 16. So y is 2, and I guess you could check that on decimals.
Well, yeah, maybe, I don't know. But you would just grid in a 2, not -2. Because they
Yeah.
say b is bigger than 0. So
Yeah,
put
you
the
can't
two-
have a
Put the
neg-
2 there. That's your answer.
Okay, so here's the work. I'll go real slow. I mean, I don't
In
know.
module 2, if you're doing really well, you might see this, you know.
You may see, I mean, this is like, I'm taking you into the deepest water with waves rolling over you. So if we have 8 squared plus 4 squared, I drew the triangle. You could use the distance formula equals c squared. So you get the square root of 8 equals the diameter. That'll be 4 square root of 5, but I have to get the radius, which is 2 square roots of 5. If you understand this one,
So you're just trying to make the equation for the circle.
I'm trying to get the equation for the circle, which I have here. And so,
Oh, and to get the center of the circle, you just averaged the x's and the y's.
yeah, I averaged the x's and the y's, and the center was -4, 0. I know, this is rough. So this would be x plus 4 whole quantity squared plus y squared, because it's just 0. And then the radius was 2 squared, so 5 squared. Lots of chance for error here. And so I put in the 4 x is 0. We're trying to get 0b. We're trying to get the y-intercept of this circle. So then I'd subtract the 16. Y squared is 4, so y would be 2.
And they just cover themselves by that saying b is bigger than 0. So
Yeah,
you
well,
can't,
any distance
well,
can
you
be.
can't put a -2
Yeah,
because b is bigger than 0.
yeah, and also any distance would have to be, or any, yeah. Okay, so let me ask, Addie, are you sort of okay with this? She is. She's still alive. Okay, Indesh?
Yeah.
Okay, Sehana,
Yeah.
Zoe Robson.
Yeah.
Oh, good, Zoe Latham.
Yeah.
Here we come, perfect math scores. Okay, I will now, we're gonna take a break.
Bring up the whiteboard and then clear it and just write down break. So it's 7:26 now. I'm fine with a 10-minute break. That was a lot of math.
Yeah, that was a lot of math.
So back at 7:36.
And then we're gonna be doing grammar 3. Do you have some book problems if you need?
I can probably find some.
Okay.
Okay, so it's 7:36, so we should be back from break. Just let me know if you are back. I'm gonna open up grammar 3.
I'm back.
Oh, thanks, Sahana.
I'm back.
Oh, thanks, Zoe.
I'm
Me
back.
too.
Okay, yeah, that's everybody then. All right, great. All right, so this is our third and final grammar lesson. So this is on both tests. This is on the ACT and the SAT. They'll test you on verb tense, they'll test you on subject verb agreement, they'll test you on parallel structure, and they like modifiers. They like dangling participles, so they'll test you on those as well. So we're going to cover all of these topics today. So let's start with tense. So verb tense just indicates when events occur. We have simple tenses, which are, as they sound, they're simple, but we also have perfect tenses, which are a little more complicated. In English, there are 6 commonly used tenses. Present tense and past tense are formed just by changing the verb. The other tenses involve helping verbs. These are forms of be, may, shall, will, has, have, had, can, do, must, and ought. And we can divide, so we can divide those 6 tenses into simple and perfect. There is simple present, simple past, and simple future. And then the more complicated tenses would be the perfect tenses. But let's start with simple present tense. Here's simple present tense. Matthew buys a laptop. This is occurring now. I could tell this is present tense just because of this verb. Morgan defeated her opponent in checkers. This is simple past, and I could tell that this happened in the past just because of this verb. And then our final simple tense will be simple future. So this indicates something will occur in the future, and so we do use a helping verb will. The Met Opera will stage Rossini's William Tell in April. So those are the simple tenses. And we use perfect tenses when there's more complex chronology. Maybe we have multiple events that have occurred in the past, and we would like to indicate which one happened first. Well, we could use the past perfect, or maybe multiple events will occur in the future, and I would like to indicate which one will happen first. And then we would use the future perfect. So I'm just going to go over these perfect tenses. Let's start with present perfect. So to form the present perfect, we use a past participle and the helping verb has or have. And it is used to express that something has occurred before now and continues to this day. So here's an example of the present perfect. I have worked as a pharmacist for many years. So we took the past participle, worked, and we use the helping verb have. And this sentence indicates that this person is still a pharmacist. That's the whole point of the present perfect. It just shows us that something has happened before now and it continues to this day. All right, next one is we have the past perfect. So we use the past perfect to differentiate between 2 things that have occurred before now. And it actually lets us know which thing happened first. So we use the past participle in the helping verb had to form the past perfect. All right, so here's our example of the past perfect. I had finished cleaning when the power went out. I can actually tell which thing happened first. Did the finishing of the cleaning happen first, or did the power go out first? Technically, the cleaning was finished when the power went out. So that's the point of the past perfect. If we have multiple events that occurred in the past, I can indicate which happened first. And the future perfect is similar. So I could differentiate between multiple events that will occur in the future, so I can tell which thing will happen first. And we use the helping verbs will and have to form the future perfect. So here is an example of the future perfect tense. Martin will have been 40 for 6 months by the time of his wedding anniversary. So which will happen first? Will being 40 for 6 months happen first, or will the wedding anniversary happen first? I can tell that he will have been 40 for 6 months first. And that's the whole point of the future perfect. We have multiple events that will occur in the future, and I can indicate which one will happen first. All right, so those are the 6 commonly used tenses. We don't really have to worry about any of the other rare tenses. Okay. So these, just a little exercise here, and don't worry about rewriting the entire sentence. All of these examples have tense problems. Maybe the sentence starts in past tense, but it ends up in future tense. Or maybe we know the sentence should be in present tense, but suddenly it, goes into the past tense. So just see if you can correct these. Let's see how many we have here. 6. So I'll just give you a few minutes to try to fix these 6. They all have tense problems. So take a little time, try these 6, and we'll go over them together. Okay, hopefully you've had a chance to try all of those. We're going to go over them now. If you're still working on the last one, that's fine too. All right, I'm going to start with the first sentence. Let's see if there's a tense problem. Just going to read it, and I'm going to try to determine what tense the sentence should be in, and then just we got to stick with it. Let's try the first one. To guarantee the safety of its citizens, a government must ensure the quality of water supplied to them. So just looking at this, the first part of this sentence right here, I think we're in present tense. To guarantee the safety of its citizens, I think that this sentence should be in present tense, the entire sentence. But if I supplied you with something, that happened before now. That's in the past. I supplied you with paper. I supplied you with a pencil. That occurred before now. So how could we fix this sentence? I think we just have to change the second half. The beginning part's fine. Does anyone want to take a shot at this one? We need to change this part. Or if you like, I'll try this one, and if you guys want to try the next one, that's fine too. So let's put it all in present tense. To guarantee the safety of its citizens, a government must ensure the quality of water it supplies to them. All right, so now it's all in present. Next one. Baking in the hot sun, we found ourselves parched and exhausted. So there are two ways we could fix this. We could put the entire sentence into the present tense, or we could put the whole thing into the past tense. We just can't have both. So however you want to try this one. Does anyone want to take a shot at this one? Number 2. It doesn't really matter. We could fix it either way.
Could it be baking in the hot sun, we find ourselves parched and exhausted?
Yeah, perfect. We could put it all into present tense. That would work. Oh, it's hard to write on this tablet. Okay, or we could put it all into past tense. Maybe I'll do it that way, just to try it. We could say baked in the hot sun. We found ourselves parched and exhausted. Now this whole sentence happened before now. It's in the past tense. As soon as you had left the room, I had beat the game. So I can tell I'm in the past perfect. But there's still a problem. Does anyone see the issue or how we should correct this one? So the simple past tense of this verb is beat, but that's not what we need here. What should it be? I beat you at checkers, but we're not in the simple past. We're in past perfect. What should that guy be? We have multiple events that have occurred before now. We have the leaving of the room and the beating of the game, and I can tell which happened first. That's the point of the past perfect. Technically, the person left the room first. It could be almost simultaneous, but technically. What should we change beat to? This one should be had beaten the game. Had beaten. As soon as you had left the room, I had beaten the game. All right, next one. If I had $1 million, I would go where I wanted. So this is something we haven't actually discussed yet, but this is what's known as the subjunctive. That's a V. And it's not even a tense. It's a mood. We have the subjunctive whenever there is a hope, a wish, a desire, a dream, any of those things. If something is not factually true, currently, it's subjunctive. And it's not a tense, it's a mood. But this is what we have here. So to formulate the subjunctive in English, we use were. I could say if I were president, or in this case, if I were to have if I were to have $1 million, I would go where I what? This is past tense, but I'm not in the past tense. If I wanted something that happened before now, I wanted attention, I wanted affection. That occurred in the past, but we're not in the past tense. And I don't even think I prefer want here. I'd probably say like. If I were to have $1 million, I would go where I like. All right, next one. So the beginning of this sentence is in present perfect. But there are problems here. This shouldn't sound correct. I have forgot where I put the money I had withdrew. So the first part of the sentence is in present perfect, and then the second part is in past perfect. But I picked irregular verbs intentionally because you're not going to forget a regular verb, but you're going to maybe forget the forms for the irregular verbs. Does anyone want to take a shot at this whole sentence? We need to correct this. We're going to get to some SAT questions in a moment, but I'm just let's make sure that we have this concept down before, we see it, how they're going to test it. I'll circle the things we need to change. Need to change that and this. And I just picked irregular verbs. That's the, because no one's gonna forget a regular verb.
Should it be forgotten and withdrawn?
Perfect, yeah. Yeah, they're just irregular verbs. I have forgotten where I put the money I had withdrawn. All right. Perfect, perfect. And same thing for this last one. It's just an irregular verb. I just purposely picked an irregular verb because no one's gonna forget the regular verb. By the time the guests had left, I had ran out of food. So I can tell them in the past perfect. I have multiple events that have occurred before now. I have the leaving of the guests. And the other thing, I'm gonna give away the answer. But there is a problem. We have to change something. It's just an irregular verb. We need the past perfect form. And it's not ran. So I ran the mile race. That is the simple past form, but that's not the past perfect form. Anyone? It's run. Oh, that's an N. By the time the guests had left, I had run out of food. That's just an irregular verb. All right, so those are tenses. They can test us on subject-verb agreement. And I'm just going to go over some rules for this. So a subject must agree with its verb in person and number. Usually they're testing the number component. So singular verb forms go with singular subjects. Plural subjects take plural verb forms. There has to be subject-verb agreement. So I'm just going to go over some rules. We're going to consider, okay, what if our subject is plural? Well, the verb is going to take a plural form. If our subject is singular, we're going to use a singular verb form, that sort of thing, because there always must be subject-verb agreement. All right, so I'm just going to go over some rules. What if we have a compound subject that is comprised of two or more nouns or pronouns? Well, the whole subject is plural in that case, the dog and the cat. So we need a plural form of the verb to be, which we have right here. The dog and the cat are inside the fence. We wouldn't say the dog and the cat is inside the fence. Sounds incorrect because it is. Because plural subjects take plural verb forms, like we have a plural form of to be right here. What if the subject of the sentence is singular? So if we have two singular entities, Wilson and Smith, but we're joining them with a correlative conjunction nor, neither Wilson nor Smith, our compound subject is actually singular. It's a compound subject, but it's singular. Singular subjects take singular verb forms. Here's a singular form of to be. Neither Wilson nor Smith is present today. You would never say neither Mr. Wilson nor Mr. Smith are present today, because singular subjects take singular verb forms. What if we have a compound subject that is comprised of both a singular entity and a plural? Well, we use whatever is closest to the verb. So this is plural. Because Anderson's, they're plural, we use a plural form of to be. But if we reverse the sentence, in our first example, neither Mr. Kennedy nor the Andersons are awake. It's just a proximity thing. So because Andersons are closest to my to be verb, I use the plural form of it. But if I flip it around and now Kennedy, singular, is closest to it, I use the singular form is. All right. Neither the Andersons nor Mr. Kennedy is awake. It's just because Kennedy is closer to the verb. All right, watch out for intervening clauses or prepositional phrases. This is one of the favorite tools of the test maker, whether it's ACT or SAT. They like to throw in a huge prepositional phrase to create space between the subject and its verb. It's just something that they do. They love to throw in a huge clause or a huge prepositional phrase. And my strategy with this is to just sort of temporarily remove it. Read a simplified version of the sentence in your head, and then you'll know, okay, we didn't have subject-verb agreement here. There was a problem. All right, so let's look at this example. Restriction of pigments that are considered toxic, such as cadmium yellow and burnt umber, are proposed by the governing body. That's one option. The other version would be restriction of pigments that are considered toxic, such as cadmium yellow and burnt umber, is proposed by the governing body. My question for you is, what is the subject of this sentence? Does anyone know? Every sentence has a subject. It's a requirement. By definition, every sentence has a subject. It's always the doer of the action. Make a note of that. So what is the subject? Just a question for you, anyone. It's always the doer of the action. Just want the subject, because then we'll figure out if there's subject-verb agreement or if we don't have it. Are the pigments the subject? Is something else the subject? Because it matters, because we have to have subject-verb agreement. If it's plural, we're going to use one of these words, but if it's singular, we have to use the other one. So the subject of this sentence is restriction. And now I'm getting to my strategy. What if we just removed the prepositional phrase? This is all there to create space. This is all there just to confuse you. This whole prepositional phrase, they're just trying to create space between the subject and its verb. So I'm just going to temporarily take it off. We don't need it. It's not going to change the sentence. All right, so which one sounds correct? Restriction are proposed by the governing body, or restriction is proposed by the governing body? It's quite obvious it's the second version, but because of that huge prepositional phrase, they create so much space between the subject and its verb that you might be confused. So once you're happy with it, you can add it back, put it back in there. Restriction of pigments that are considered toxic, such as cadmium, yellow, and burnt umber, is proposed by the governing body. So that's my strategy. Just temporarily take out the huge prepositional phrase or clause or whatever it is. Simplify the sentence in your head, and that way you will instantly know what's correct or incorrect. So this next section here we're going to do just a little exercise on everything we just covered. Subject-verb agreement. I see some prepositional phrases, so I can already tell they're trying to create space between the subject and its verb. So for some of these, you might want to just cross off right on your page. You know, you can always add it back later. Take some of the sentence out if that makes this easier. You can always add it back in. You know, maybe we'll just do these together. There's only 4 here. Let's start with the first one. All right, neither the issue of voter fraud nor the miscounting of votes found their way to the Senate floor. So I have a compound subject joined by correlative conjunction nor. And let's figure out if my compound subject is singular or plural. So issue is singular. Miscounting is singular. So my entire subject is singular. It's a compound subject, but the whole thing is singular. Okay. This is a plural possessive pronoun. So we have a contradiction here. Something do we know to be singular can't just suddenly become plural. How should we fix it? I'll let one of you guys try it. We got to just pick a different possessive pronoun. Something singular. Anybody?
Is it it?
It is. Good. All right. So, because it's singular, we needed something singular. All right. Excellent. Next one. The recent deep sea discovery of the prokaryotic microbes with eukaryote-like genes have fascinated scientists worldwide. I think this huge prepositional phrase is only here to create space. It's only here to trick us. So we can just ask ourselves, okay, what is the subject of the sentence? That's one way to approach this. Or I can just cross this whole phrase out. We don't really need it, at least temporarily. I'm going to read the simplified version of this. Would any junior in the country miss this? The recent deep sea discovery have fascinated scientists worldwide. Well, that sounds weird. If my subject is singular, why do I have a plural verb form? All right, that sounds better. The recent deep sea discovery has fascinated scientists worldwide. Now that I'm happy with it, let's add the prepositional phrase back. The recent deep sea discovery of the prokaryotic microbes with eukaryote-like genes has fascinated scientists worldwide. They just love to create distance. And the clock's ticking, you're trying to answer all these questions, so you might get distracted because they just, it's all there just to confuse you. Are the microbes the subject of the sentence? Is the subject plural? Are the genes the subject of the sentence? This is the subject of the sentence. So I find that if you just simplify it, it makes this an easier task. All right, next one. New understanding of different social mores and folkways are inspired by the work of modern sociologists. So when in doubt, we could find the subject, figure out, okay, is our subject singular or plural? So we have a plural verb form right here. This is just the to be verb. But what is my subject? And I'll probably do it the other way. I'll probably cross off half of the sentence and try it that way too. But just a quick question for the group. What is the subject of this sentence? Every sentence has a subject. Are the mores the subject, which would be plural? The folkways, those are plural. But maybe something else is our subject. You know what? I'm going to cross off half the sentence. Let's try it that way. We don't need this prepositional phrase. It's only there to confuse us. Does this sound correct? New understanding are inspired by the work of modern sociologists. Does that sound correct, or does this sound correct? New understanding is inspired by the work of modern sociologists. So that was my subject. Understanding is singular. Bear with me, it's hard to write on this tablet. I don't know how Mrs. Hessler does it for all those math questions. Singular. So that's singular. So it needs a singular form of to be, which would be is. New understanding is inspired by the work of modern sociologists. Now that I'm happy with the sentence, let's add the rest of the prepositional phrase back. Because they're just trying to trick you. They're trying to make you think that something plural is the subject of the sentence, but singular subjects take singular verb forms. It's just how it works. New understanding of different social mores and folkways is inspired by the work of modern sociologists. Next one, the substantial cost the company had to invest in computer processing and expanded networks were recovered by the greater influx of online orders. They're just trying to create space between the subject and the verb. I'm going to cross out, a huge portion of this sentence. Would anyone miss this? The substantial costs were recovered by the greater influx of online orders. That doesn't sound right to me. So our subject is singular. Yet here I have a plural verb form. Let's fix it. The substantial cost was recovered. Now that I'm happy with the sentence, let's add everything back. The substantial cost the company had to invest in computer processing and expanded networks was recovered by the greater influx of online orders. So they're definitely going to test you on subject-verb agreement. I like to just simplify it in my head, maybe remove a big chunk of the sentence. There's no limit to the length of a prepositional phrase. A prepositional phrase can be 20 words long. And it may be hard to realize, okay, is my sentence, is the subject of my sentence singular? Is the subject of my sentence plural? By the time you get to the verb, you might forget, there might be other plural things that are, you might think, oh, is that the subject? But if you just simplify it, you'll know right away. So I like that strategy for that type of question. All right, they will test you on parallel structure. And I'm sure your English teachers have been drilling you on parallel structure for years. So we like to have parallel structure in certain situations in English. It just creates balance. It makes your writing much easier to understand, and it's, more powerful, just better. It's better all around. And I'm going to go over all the situations in which we like to have parallel structure. So we like to have parallel structure when it comes to verb forms. So we can have ing verb forms, that we can have gerunds. We can also have infinitives. To be, to hike, to swim, to surf, to backpack, any of those two forms, those are infinitive forms. And the idea here is that it is incorrect to mix them. Just pick one or the other. We can pick the ing forms. We can pick the infinitive forms. Just maintain form, verb form. Tom likes backpacking, fishing, and to surf would be incorrect. So here I have two gerunds and an infinitive. And the way we would fix this is just to pick one or the other. I could say Tom likes backpacking, fishing, and surfing, or I could use all infinitive verb forms. It doesn't matter which one we select. We just have to be consistent. Tom likes to backpack, fish, and surf. Note that you don't need to repeat to 3 times. I don't need to say Tom likes to backpack, to fish, and to surf. We only need it once. All right, so just pick one or the other. I'll give you another example just because this one kind of just occurred to me. To be or not being, that is the question. You see how strange it sounds when we don't maintain verb form? So to be or not to be. I'm just going to stick with the infinitive form, and it sounds so much better. All right, next thing. We like to have parallel structure when it comes, when we have adverbs and prepositions. All right, so here is an example. We expect you to arrive, verb number 1, punctually, adverb number 1. Work, verb number 2. Skillfully, adverb number 2. And leave, verb number 3. Prepositional phrase, at a consistent time. That's horrible, right? So let's just fix it. We expect you to arrive punctually, work skillfully, and leave consistently. It sounds so much better. All right, parallel structure. We like to have parallel structure with clauses. Kelly told the babysitter that Megan must study, that Jack must clean, and to all take showers. That's not parallel. Let's make it parallel. Kelly told the babysitter that Megan must study, Jack must clean, and all must shower. We like to have parallel structure when we have lists. And the main reason you'll see a colon is when you have a list. All right, so here's an example of this. Today we had quite the breakfast. I just want nouns after my colon. That's all I need are nouns. Fruit, French toast, and pancakes, passive voice, were also made for us. That sounds horrible, right? So let's make it nice and parallel. Let's just have nouns. Today we had quite the breakfast, fruit, French toast, and pancakes. It sounds so much better. All right, so we're going to try to make these parallel. I think there's only a few of them here, so I think we'll just do these together. All right, the commentary. They will test you on parallelism. The commentary after the televised debate was insightful. Adjective. Thorough. Adjective. And kept us engaged. All right, we need to make this thing parallel. What would be my third adjective? I'll let someone chime in. I'm actually kind of looking forward to another debate if it happens. I don't know if it will. I doubt that the commentary will be insightful, thorough, and whatever this third thing is, though. What goes here? We just need parallelism.
Would it be engaging?
Yeah, perfect. Engaging. Excellent. All right, next one. Let's make this parallel. To donate to a worthy cause is giving back to the community. It's not parallel. So here I have an infinitive verb form, but here I have a gerund. And we could fix this either way. We could use all ing forms. Maybe I'll fix it with infinitives, just why not? To give back. To donate to a worthy cause is to give back to the community. That would be fine. We could fix it the other way. We just can't have both. It's not parallel. All right, donating to a worthy cause is giving back to the community. Next one, or final one here. Derek supports free market capitalism, reduced bureaucracy, and not depending on foreign oil. So it sounds to me like Derek supports adjective noun things. Free market capitalism, reduced bureaucracy, and not depending on foreign oil. We lost the parallelism. Let's see if we can get it back. And I'm going to cheat a little. I'm going to hyphenate something. All right, here's the sentence. This is parallel. Derek supports free market capitalism, reduced bureaucracy, and foreign oil independence. All right, next topic. We have dangling participles. So dangling participles, well, we better introduce what a participle is. In English, we have present and past tense. Yeah, we have present participles and past participles. So present participles would be those ing forms: dancing, swimming, biking, camping, hiking, fishing, any of those ing ones. But we also have past participles: written, spoken, and whispered. And dangling a participle is when you put it in the incorrect place in your sentence and it modifies the wrong thing. It's a misplaced modifier. So let's take a look and see a dangling participle. So I am going to highlight the participle. It's right here. And there is a problem with this sentence. Mother opens the door wearing pajamas. Can a door wear pajamas? That's a dangling participle. And you may say, well, Mr. Hessler, of course I can infer that mother is wearing the pajamas, not the door. That's not what the sentence says. Technically, the door is wearing pajamas. That's what a dangling participle is. So to fix it, we just need to put the participle closer to the thing it's modifying. Mother, comma, wearing pajamas, comma, opens the door. So that's a dangling participle, but you can dangle a whole participial phrase. So I could take a participle and I could just add some words to it to make a phrase, but you could dangle that, you could modify the wrong word with your dangling participial phrase. So here's the participle. Hoping to succeed in the interview, long hours are spent by John in preparation. Okay, so can hours of the day hope to succeed in a job interview? And they can't, right? It has to be John. John has to go here. He is the hoper. And that's all a dangling participle is. So here's how we fix this one. Hoping to succeed. Oh, I didn't mean to cross it off. I'm trying to highlight it. Hoping to succeed in the interview, John spends long hours in preparation. So now John is where he needs to be. Now hoping is modifying him and not something else in the sentence. So it's not too difficult of a concept. Just watch out because they will test you on this. Let's try a few of these together, and then we're going to get to some SAT questions in a little bit. All right, so let's try this. Thoroughly lacking cohesion. Jake is not proud of his term paper. So I'm going to highlight the participle because I think that is a good way to approach these. And then we'll think about how we should correct this. All right, thoroughly lacking cohesion. If Jake thoroughly lacks cohesion, that means Jake is a puddle of goo on the ground. And I think that's why they put these on the SAT, because they're funny. Thoroughly lacking cohesion, it has to be the paper. It can't be Jake. So to fix this, I'd probably say thoroughly lacking cohesion. Jake's term paper brings him no pride. Or you can even say, I'd probably just say Jake's paper is inadequate. Thoroughly lacking cohesion. Jake's term paper is inadequate. But it just has to be the paper. The paper needs to be where Jake is. So however you want to fix that one, it just can't be Jake. If Jake thoroughly lacks cohesion, Jake has a bigger problem than the term paper. Jake is a puddle. All right, next one. You can dangle a past participle. Here is a past participle. Written in stone, the Babylonian king Hammurabi included in his legal code the presumption of innocence. Interesting. And we still have a presumption of innocence in our legal code. That's kind of cool. I didn't remember that. All right. Written in stone. But can a king be written in stone? Makes no sense. So we need to fix it. Written in stone. I'd probably say the code of Hammurabi. Written in stone, the code of Hammurabi included within it a notion of a presumption of innocence. All right, here's my full sentence. Written in stone, the code of Hammurabi included within it a notion of a presumption of innocence. So now the code is written in stone and not the king. We fixed it. Here's the last one. Endangered, the diminishing numbers of giant pandas caused Trina to feel concern. All right, so I'm going to highlight the participle. And this one's actually interesting because we sort of have a double negative here. So just like in math, if we multiply two negative numbers, you get out a positive number. In English, you can have a double negative, and you can often say the opposite of what you intend. So wrap your head around this one. But if the diminishing numbers of something are endangered, that would actually mean more pandas. Yeah, just double negative. So yeah, if the diminishing numbers of something are endangered, you're getting more of that thing. So we have a dangling participle here. It's not the diminishing numbers that are endangered. It's just the pandas, right? All right, so endangered, the giant pandas caused Trina to feel concerned. So now the pandas are endangered, and yeah, that makes me sad. I think they're no longer endangered. I think they maybe just threatened at this point. I think they've been upgraded. But anyway, now this is modifying pandas, and it's correct. All right. Now we have some SAT questions. And the ACT would be similar. So anytime you see this on an SAT, all they're doing is testing you on grammar. If they're asking you about the conventions of standard English, that's just a wordy way of saying, hey, this is a grammar question. So try them all. We'll go over them, and then that'll be it for tonight, I think. So try all of these. It looks like there are 9 total. This is everything we went over today. This is subject verb agreement. We got dangling participles, probably parallel structure. So try these, just try these ones. We'll go over them and then that'll be it. All right, I'm running out of time, so I am going to go over these. If you're still working on the last one or two, that's fine too, but just in the interest of time, I'm going to go over the exercise here. And I tried to jot down little notes about what tense we're in or what I think that they're testing you on with each question. So let's just do the first one. We just have to do a few of these and we're done. All right, I'm going to read the question. An art installation at the Smithsonian presents the collaboration between two free African American artists who worked in Cincinnati, Ohio from approximately 1845 to 1855. Photographer J.P. Ball and landscape painter Robert S. Duncanson. Ball employed Duncanson to hand tint his photographs. I think we're in simple past. Although Ball photographed African Americans such as Frederick Douglass, this exhibition highlights the frequency with which white families and individuals patronized Ball. So this one is A. We just need the simple past. They will test you on tense. Next one. This looks like it's another tense question. The global mean water level in the world's oceans rose 0.14 inches per year from 2006 to 2015, which was 2.5 times the average rate of 0.06 inches per year throughout most of the 20th century. The Intergovernmental Panel on Climate Change has projected that by the end of this century, global sea levels blank an estimated 12 to 43 inches, depending on different emission scenarios. So here we have multiple events that will occur in the future. We have the ending of the century, and we have the rising of the sea levels. So I need the future perfect. Let me read the corrected version. The IPCC has projected that by the end of this century, global sea levels will have risen an estimated 12 to 43 inches. Number 3, chronic wasting disease is a transmissible spongiform encephalopathy, that's hard to say, known to only infect members of the cervid family, deer, elk, reindeer, caribou, and moose. Caused by misfolded proteins called prions. Here we have a dangling participial phrase. I'm going to highlight the participle. Caused by misfolded proteins called prions, the disease is highly contagious and always fatal. Next one. CRISPR consists of 2 components, the Cas9 enzyme that can cut a sequence of DNA and a guide RNA that interprets the sequence of DNA to be modified. Researchers hope blank CRISPR to cure congenital diseases. All right, so for this one, I made some notes about these different forms. Are we in the simple past? I don't think so. Present infinitive would be the correct version here. Researchers hope to use CRISPR to cure congenital diseases. On to number 5, it's another tense question. Alma Thomas was successful as an African-American female artist in spite of the segregation and discrimination prevalent during her time period. In the mid-60s, she developed a unique painting style. This one is simple past. Number 6. All right, utilizing methane, ammonia, hydrogen, and water, the scientists demonstrated the conditions present in a prebiotic Earth atmosphere could permit the synthesis of complex organic compounds. The scientists, I'm just going to highlight the participle, they're the only utilizers we have. So nothing else can follow that comma. It has to be the scientists. Number 7. Oh, it's another one of these. Past participle, I'm going to highlight it. Composed of 2 adjoining black granite walls. The memorial bears the names of 58,320 soldiers who died or remained missing as a result of the Vietnam War. Composed, I have to put whatever is composed right there. And it can't be this artist. A person can't be composed of 2 adjoining black granite walls. It's just a dangling participial phrase. On to number 8, deltas are born out of the interaction between rivers and oceans. As the river merges with the calmer marine environment, the river loses its velocity and deposits its sediment. And then here's our final one. Okay, so we use the present perfect to indicate that something has happened before now and continues to this day. The ancient Romans enhanced the strength of concrete by mixing volcanic ash with lime, producing a very durable material. Roman structures such as the Colosseum have withstood centuries of exposure to the elements, and many are still standing today. All right, so that one was present perfect. So just mark down how many you got right out of 9. Write it down on your paper. I think it's 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 good to be honest about this. Just jot it down. If you're getting 4 or 5 of these correct, that would be a 500. That would be the average English score. If you're getting 8 or 9 of these correct, you're probably in the 700s. Okay, so I just wanted to remind everyone to take a practice test. So take a practice test. If you haven't taken test 2 on the digital SAT, take that. If you're gonna take an ACT, that's fine too. Just take one. So I just want to remind you of that. And that's it. I think that's all we have. So we'll see you next week at 5:30. So we'll send you the Zoom invite as we always do. But please just take a practice test. It really is helpful. I think many of you will probably be, you might increase your score 100 points. I'm not joking, because that's five English questions and 5 math questions. I don't know why it likes to mess with me. I don't know why I like to turn my E into something weird there. I did it again. Whatever. You get it. That's 10 questions. If you can answer two or three more questions correctly per module, you just raised your SAT score 100 points. It sounds insurmountable. 100 sounds like a big number, but it's 10 questions. So just take a test, and we'll see you guys next time. That's all I have. So I'm just signing off. So if you want to sign yourself off, and we'll see you next time.
Thank you.
Thank you.
Oh, thanks,
Thanks.
Thanks, Sahana. Thanks, everyone. See you guys next time.